In 2004, a graduate student typed a number into a computer, and the number said we were going to die. Not metaphorically, but a real number, a probability, 1 in 37. An asteroid that's heading for Earth on April 13th, 2029. That asteroid is named Apophis, named after the Egyptian god of chaos. They didn't pick that name by accident, and here's the detail nobody mentions clearly enough. April 13th, 2029 is a Friday. Friday the 13th. Now I know what you're thinking. They said it won't hit us. The math was corrected, but this is old news. You're right. The revised calculations are clear. It won't hit us in 2029. So then why? In a room full of the most analytically calm, data-driven humans on Earth, are the scientists studying this thing still not sleeping well? Because what they found inside that near miss isn't a comfortable near miss at all. It's something that has no historical precedent, no reference case, no comparable event in the entire era of modern astronomy, and they're sending not one, but 2 spacecraft to watch it happen live from point-blank range in real time. So let's talk about what is actually coming. Apophis is roughly 340 meters across. Let that number settle. 340 meters isn't an abstraction. That's the height of the Chrysler Building in New York, and the full length of 3.5 football fields. It's an object you could photograph from a helicopter and recognize immediately as something enormous. Now give that object a density of iron and silicate rock. Pack it full of ancient solar system material. Set its mass at roughly 79 billion kilograms. Now throw it through space. Apophis travels at 7.4 kilometers per second, relative to Earth at closest approach. That is not a typo, not a metaphor for really fast. That is 8 times faster than a rifle bullet. It covers the distance from Berlin to Rome in under 2 minutes. If Apophis hit land, anywhere on land, the immediate vaporization zone would erase everything within hundreds of kilometers. The shockwave would travel further than that. The thermal pulse would cause spontaneous ignition far beyond the blast radius. The ejected debris cloud would disrupt global temperatures and agricultural cycles for years. The energy released at impact would be approximately 900 megatons of TNT. That is 18 times more powerful than the Tsar Bomba, the largest nuclear weapon ever detonated in human history. 1 rock, 1 impact, and that's a moderate estimate. Some models run higher. But here's the thing. We've known about Apophis for over 20 years. We've tracked it obsessively. We've updated the orbital data dozens of times. We know with extraordinary precision where this rock is going. So why does this specific event, the 2029 flyby, feel different? Why is it triggering a global mission response rather than a quiet, we're safe, move on? To answer that, you need to go back to the night the fear started. Because the story of Apophis isn't just about an asteroid. It's about what happens when science encounters a number it didn't expect. June 19, 2004. Kitt Peak National Observatory, Arizona. A survey team was doing what survey teams do, scanning wide patches of sky, logging faint objects, looking for things that moved against the fixed star background. Standard procedure. They flagged an object, barely a smear of pixels, so dim it was right at the edge of detectability. They gave it a provisional designation, logged it, moved on. This happened thousands of times per year. Almost none of these objects matter. Almost none of them come anywhere near Earth. 6 months passed. December 27th, a team ran updated orbital calculations. They gathered new data points, new observations. They plugged the numbers into the model. And then, someone in that room said, "Stop. Check this again." The probability wasn't 0. In the world of near-Earth object tracking, the baseline assumption when you log a new rock is that it's essentially harmless, a distant flyby, a large margin, nothing to worry about. You'd need a truly staggering coincidence of geometry and timing for something to actually threaten Earth. But this number said otherwise. 1 in 37. To put that in context, you have better odds of rolling a specific number on a standard die. 1 in 37 is not a rounding error. It is not background noise in the data. It is a number that, in the entire cataloged history of asteroid science, had never appeared for an object of this size. Not once. And the potential impact date, April 13th, 2029. For a period of hours, while scientists checked and rechecked, NASA held a number that the rest of the world didn't know about. A real, non-trivial, mathematical probability that a civilization-threatening rock was aimed at Earth. More data came in. The probability began to drop, then lower still. By March 2021, after radar measurements so precise they could track Apophis's position down to within a couple of kilometers, Scientists announced no impact in 2029, none within the next 100 years at minimum. Apophis is not going to kill us, but here's where the story gets stranger. Because ruling out the impact didn't end the fear, it transformed it into something more specific, more scientific, and in some ways, far more fascinating. In orbital mechanics, there is a concept called a gravitational keyhole. It's a small, precise region of space, sometimes only a few hundred meters wide, that lies in the path of a passing asteroid. If that asteroid threads through the keyhole, Earth's gravity subtly bends its trajectory, recalibrates it, sends it back toward Earth on its next orbital pass, years later, on a collision course that didn't exist before the close approach. In 2029, Apophis is going to come so close that scientists had to calculate in extraordinary detail where the gravitational keyholes were sitting inside its approach corridor. The question wasn't just, will it hit? The question was, will it pass through a keyhole and be steered onto a future impact trajectory? The answer, after years of radar tracking and refined calculation, is no. There are no keyholes in Apophis's 2029 path, but to arrive at that answer, they had to calculate just how close it would actually come, and that number changed everything. At closest approach, Apophis will pass approximately 31,600 kilometers from Earth's surface. Our geostationary satellites, the ones broadcasting your television, powering your weather apps, enabling global navigation, orbit at roughly 36,000 kilometers. Apophis will fly closer to Earth than those satellites. This is not a distant, barely visible, near miss. This is an asteroid threading the needle through our technological infrastructure at interplanetary speed. If the orbital calculation were off by even a small fraction, compounded over years of trajectory, this would be an entirely different conversation. But there is something else hiding in that distance number, something the planetary scientists are more focused on than the impact risk itself. When any large mass passes that close to Earth, our planet's gravity doesn't just let it pass, it grabs at it, it stretches. The tidal forces exerted on Apophis during the 2029 flyby will be strong enough to cause physical changes to its surface. We're not talking about theoretical perturbations. We're talking about seismic activity, rock slide events, the opening of stress fractures that have been locked shut since the early formation of the solar system. 4.5 billion years ago, material from the deep interior of this asteroid, pristine, ancient, unweathered by solar radiation because it has been sealed underground for longer than Earth has existed, could be pushed to the surface. Cracks will open, layers will shift. An asteroid that looks one way before April 13th will look measurably different after it. And nobody has ever watched this happen before. Not once in the entire history of human observation has an asteroid of this size passed this close to Earth, while we had the instruments, the orbital knowledge, and the spacecraft capability to study it in real time. An event like this occurs approximately once every 7,500 years, and that is exactly why the spacecraft are already en route. OSIRIS-APEX has a resume. Its predecessor mission, OSIRIS-REx, traveled to asteroid Bennu, spent 2 years orbiting it, descended to within meters of the surface, fired a burst of nitrogen gas at the ground, collected the debris that erupted, sealed it in a sample capsule. ANF returned it to Earth, dropped that capsule in the Utah desert in September 2023. It was the largest asteroid sample ever returned to Earth. Scientists are still analyzing it, but the spacecraft didn't stop. It wasn't done. Renamed OSIRIS-APEX, it banked off Earth's gravity and set course for Apophis. Right now, it is coasting through space on an intercept trajectory. When April 13th, 2029 arrives, it will arrive at the asteroid approximately 1 hour after closest approach to Earth, 1 hour after the tidal forces have done their maximum work. A geologist arriving at a landslide site while the dust is still in the air. It will then spend 18 months in orbit around Apophis, mapping the surface while also measuring the density, listening with instruments sensitive enough to detect the faintest gravitational field variations for the echoes of whatever restructuring happened inside. And at some point during that 18-month mission, OSIRIS-APEX will do something that sounds almost absurdly bold. It will descend to within approximately 15 feet of the surface, and it will fire its thrusters directly at the ground. Not to collect a sample, just to blast, to deliberately kick up rock and dust from beneath the surface layer. to expose whatever is hiding underneath, to give the instruments on board a direct look at material that has never been disturbed since the early solar system. Meanwhile, the European Space Agency is sending their own spacecraft, Ramses, to arrive before the flyby. So there will be a before picture and an after picture, and 2 probes watching the transformation happen in real time. On the evening of April 13th, 2029, if the sky is clear and you are standing in Europe, across North Africa, or into parts of Western Asia, you can step outside, look up without a telescope or anything else, and you will see it. A star that moves fast enough to watch with the naked eye in real time, crossing nearly a full moon's width of sky every minute, closer to you at that moment than the satellites processing the signal on your phone.